So welcome guys. So we have a session today unlocking the geospatial analysis with PostGIS. It's just an introductory talk about the PostGIS, and my name is Ibrar Ahmed, and welcome to the Percona Live. So spatial data storage actually, if I go, what is the spatial data? Spatial data with location. That's the bare minimum definition of spatial data is data with location, which involves location. Can be represented using points, line, polygons, and geometrical shapes. And where you can use that? Land, transportation, natural resources, climate changes. So this is the usage of geographical data. So storage, if we want to store that data, we need a database. Absolutely. If we want to store any data, we need a database. So for spatial data, we can store that into a relational database. All right. We can store a spatial database, which is built for that purpose, and we can cloud-based storage. We can store in a cloud-based storage. So these are the three options. But here we will talk about the mixture of relational database and portion of spatial database. So I will explain you how you will do that. So what software can you use the database? The GIS software, statistical software, and the machine learning software. This can use that data. If data is properly stored, then we can manipulate data using this application. So that's the data we want to store. And how we can store? PostgreSQL as a relational database we will use to store the geospatial data. But when we store that data, we need some special functionality. We can store, again, we can store geospatial data in PostgreSQL without any support, but it's difficult to store and manipulate the data in PostgreSQL. So there should be some tool, some extension that required to do that task. So I will explain how we can achieve that and what's the problem when we are not using the extension. And PostgreSQL provide a mechanism, a pluggable extension. You don't need to compile your PostgreSQL code. You just take PostgreSQL code, write an extension for that, load that extension. So that's it. You don't need to change the actual PostgreSQL code. It can be in C, C++, Java, PLP, SQL. Any language you can write an extension, and that extension can be used in PostgreSQL. So once installed, you can run the queries as it is the part of the PostgreSQL core. So don't need to change PostgreSQL. You have an extension. You can write the extension in any language. You install the extension, and it behave like it's a part of the PostgreSQL. Okay. Extensions can be a great way to add a new feature and functionality to PostgreSQL. And we will use that same concept for the GIS data. So here comes. I described you PostgreSQL relational database, and we need some special handling for geospatial data. And that is a PostGIS. That is an extension. PostGIS is an extension to PostgreSQL database and add the support for spatial data. I told you, you can store the data in relational database without any extension, but you need some support, and that support provided by the PostGIS. In an extension, you install the extension, and you can manipulate, you can add, update, delete, query geospatial data from PostgreSQL using PostGIS. So this is the combination of PostgreSQL, PostGIS, and that become a geospatial database. So PostGIS provide wide range of feature for working with spatial data, such as graphics object, point, line, and polygon. Keep in mind, there is a three things geospatial data or geometrical data required. One is a point. You need to store a point. Point is just like this. This is a point. And second, you need a line to represent a line. When we say line from this point to this point, a line connects 2 points or 2 or more points. Like this point to this point. If anything connect to this is line. This point, line. This point, line. This point, line. And when these lines join, the starting point and the ending point is same, then it's called a polygon. Like this is point, this is line, and this is line. And that makes a polygon. So any shape polygon, just the combination of line where starting point and ending point is same, then it's a polygon. So that's 3 components required for storing the data. The point, the line, the polygon. When you can do that, you can manipulate data as much you can.
Is PostGIS distributed with PostgreSQL together, or you have to?
Yeah, there's 2 things. PostGIS is an external extension. It is not delivered with PostgreSQL, but we have a plan to include that in next quarter with Percona distribution for PostgreSQL. So when you do Percona distribution for PostgreSQL, you will get PostGIS and support for the PostgreSQL. It's same. Percona distribution for PostgreSQL is same, but it's a bundle. It's a bundle of different tools where you can get the PostGIS too. But the PostgreSQL is 100% vanilla PostgreSQL. All right. So I told you that these 3 things actually, the point, line, and polygons. So you need to store that, and you have to access that. So then these are the 3 things you need to store, and you need to have some indexes, like to get the data quickly. You need to create indexes. You need to join spatial data. You need to query the spatial data, right? So this is the storage and then the manipulation of data. That's only the requirement. How we will do that? I will let you know in next slides. So installing PostGIS. So it's really easy. Just and if you are on Ubuntu, apt-get install PostGIS, and then in CentOS you can install it using yum. PostGIS support data types including point, line, polygon, and geometrical collection. Geometrical collection is the same. It's already created geometrical collection. So these data type is point. You can store a point. Line string, you can store a line. Polygon, you can store a polygon, and you can store a geometrical collection. So these are the basic thing, 3 basic thing you can store. When you are able to store that, then you are able to manipulate that data. A point, a single point space defined by x and y, especially z or more coordinate. Line string, a sequence of 2 or more connected points, is called line. A closed shape defined by the sequence of point represented area in space. So if this is this collection of 0 or more other geometrical objects. So you can store multiple objects of that. That's really basic. So here we will insert some data because it's just an introductory PostGIS. So what you have to do, you have to just install the extension and write create extension PostGIS, that it will install. And then we are creating a table, create table, and there's the primary key, name, location, and the geometry at the point. This. We have inserted the data of the states here, some of the data. It's just the data we inserted in the PostgreSQL. And data types exists is a point and geometry. This is from the PostGIS. So if we want to create a line between 2 locations, so like we want to have a one location 1 and location 2. In city 1 and city 2, want to make a line between them. So it's keep in mind, line doesn't mean it will draw a line. It will store that information only. It will give you the coordinates of that. That's it. It's not storage, the physical line of that. But using that, if you have a graphical tool, using that, you can draw a line yourself. Like if you go to the Google Maps Google Map, you just calculate the distance. You have this coordinate and this coordinate. You are giving that and ask calculate the distance between them. It will give you the distance, and PostGIS has a function distance where you can give you the 0.1 and 0.2, it will give you the distance. So it will not putting a line there, it's just storing or giving you the coordinates of the line, that's it. So here we are asking to create a line string geometry using the ST. Actually, the most of the function in PostGIS is ST underscore and then the function name. So you find that it's a PostGIS function. So ST make line. We are making a line between C1 location, C2 location, and the same table is same. Cities C1, cities C2 is just alias C1, C2, and C1 name is New York and Los Angeles. So it will make a line between New York to Los Angeles. It's quite simple. It's not that difficult. A distance calculation. That's what I was telling you. To calculate the distance between New York and Los Angeles. Wow. What is the way of doing that? Just forget about the first one. Look at the second one. ST underscore distance is a PostGIS function, right? And we are providing the location, C1 location, C2 location, as distance, cities, New York and C2. It will give you the distance between New York and, because location is the coordinate of Los Angeles and New York. So it will calculate the distance between them. Suppose you don't have PostGIS, then you have to write this query to calculate the distance. It's pure mathematics. You have this, you have to calculate this, you have to sign, you have the power, you have the pi. So you have to calculate this distance because cos, power, sine. So you have to write this whole query to calculate the distance between 2 points. But here you have ST distance. So both in a relational database, both the queries are from PostgreSQL. But here we have done a SQL query simple without PostGIS, and we have done the query with PostGIS extension. That's the simplicity it provides. I told you in the beginning that we can achieve geospatial data using relational database without any GIS information. But it is that difficult. I just want to show this. So you have to be a mathematician like this for at least this kind of a thing. You have to write it yourself. And result will be the same. So ST distance is a function, you can use it. Polygon. So create a polygon representing the bounding box around the group of cities. So like if you have a Los Angeles, New York and Denver, you can say that. So you want to make a box around that. Sometimes you just box it and ask that the distance between something like that, you create a box. Even you see that in Google Maps or maps, you just create a box and you can see how many cities are in there. So you want to create a box of that cities. So New York, Los Angeles, Chicago, Houston and Phoenix. So you can create a box like this. You can create a box here, 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 here. You can create a box. So ST, convex hull, ST collection, location, and this is the function as a bounding box, as is the name of that. So it will create a box. When this box is created, you can, like I will go back to the, sorry. Why is, oh, sorry, sorry. So if you create a box between this is a box. The box is created. And you want to check if there is one city here, like this is box, and this is not in the box. And you have this point. You create a box and then ask the PostGIS, is this point or this city in that box or not? That is the purpose. You have created a polygon from this to this to this to this to this and this. Polygon is created, and then you query the PostGIS, is this city in that box or not, in this polygon or not? So it will tell you yes, it is or not. It's not drawing anything, it gives you the answers. So usually you just, in Google Maps, you just circle it out and ask the city is in that circle or not. It will tell you yes, it is or not. So it will create a first a polygon, and then we give you the point that is that point in that polygon or not. Okay, polygon is done. Okay. So here, this will create a, we already created a point, we don't need to create a point. We already created a line, we created a polygon, we want to create a geometrical collection. So here, we are creating a geometrical collection where we have a point, line string, and we call it's a geometrical collection. Select it, and we have as geometrical collection. So it will create some, using that coordinates, we just provided some coordinates. Most probably you know the coordinates. If you have a geospatial interest, so you know the longitude, latitude, and that's everything. So you know that. So special function and its PostGIS function. So like st distance, st buffer, intersect, centroid, transform. So these are actually, if you want to get the list of this, it's hundreds of functions available. So I can't list it, every function is. Like, what is the intersect? Intersect, like if you have one circle here, one polygon here, and one polygon here. So find the intersection between the two polygons. So it will give you the intersection. Create one polygon, create another polygon. Find if there is any intersection is there or not. If yes, it will give you the coordinates of intersection. So distance, the buffer, the transform, we will see what is the transform is. Distance, I already told you that if you want to calculate distance between two cities like New York and Los Angeles, it will give you the distance between two. So SRID, special reference identifier. So it's an identifier, special reference ID. So between special reference ID 1 and between. Now if you see in the first slide where we inserted data, we added this special reference ID in the table. So using that, it is calculating the distance. So st buffer is a PostGIS function to create a buffer or a zone of specified, we create a buffer zone around a given geometry. The buffer can be either a circle, polygon, depending on the value of this value. So it will create a location, it will create a 5,000 around meter buffer around that. So like you have a city like this, if you want to create a buffer around it, like circle or polygon, it will create a circle like that. It's look weird what is the purpose of these functions or not, but you see that sometimes you just expand that, it will create a blue circle in a Google Maps. The city is there, you create a blue circle. It's create a buffer zone around the city. So this function will do that. So it is doing around the Chicago. So intersection. So we are creating the buffer to buffer Dallas and st buffer Houston. So we actually, you know that when we are calling the Houston, we are calling the Dallas, that's only the points. These are the only points, that's the whole city. But we are creating a buffer, that city is around 5,000 meters. We are assuming that it's a circle is 5,000 meter. And we creating a 5,000 meter buffer around one point of Dallas. Like Dallas is this, but actually Dallas is like this. It's a big 5,000 meter or 500,000 meter, big enough. So we created a buffer of 5,000 meter around Dallas, and we create a 5,000 buffer around Houston. And we can see that, is there any intersection between both of them? Because the both are not circle. It can be a polygon. So some areas are intersect between the Houston and Dallas. Some intersection is there. So The purpose of that, you can see that it's usually used in our countries, is used for the police stations. Like the police station have this polygon area and this police station has this polygon area. And we can find the intersection. There should be no intersection between that. But there is a collide that this area is in this police station or this area is in this police station. So you can find the intersection. Centroid is the PostGIS, the function centroid is used to find the geometric centroid of the spatial data such as point, line, paragon. So you just call the st_centroid. Calculate the centroid of polygon created by the buffer around San Diego. So we already use 5,000, but you can change any values in that. Transform. So here SRID. st_transform is a PostGIS function that allows you to convert geometrical spatial reference system from one coordinate system CRS to another. There is a multiple systems available for geometrical. So using this transform, you can change that. So I am also not expert in geometrical values. I can only give you the database point of view, but anybody who is geospatial specialist who knows how this works actually. I can only give you the database aspect and the query, how to do that. So, okay. We already discussed that we have a storage mechanism where you can store point, polygon, line, and we have query them using the different functions of PostGIS. But the problem is if you insert a data like millions of record, a billion of record on that on points, so the database becomes slow, the query becomes slow, but in that time you need to speed up your queries. And you can create an index on that. And GIST, actually the GIST index is the index where you can create a GIST index on spatial data. So you can see that using GIST, it's a generalized index and it's a framework where you create your own index. Because if you have a data like int, string, this kind of a data, you have a default B tree, hash, bin, you have that kind of an index in PostgreSQL. But this GIST is a framework where you have a complex and composite values where you want to create an index. So GIST is for that. So you create an index GIST on my table using GIST, and this is the value of the column. And select static from this and this function, and you will get the better result from that. So only this, the way of creating an index is the best way is the GIST index you create on your spatial data. If you have an integer, string, anything, so you don't need to go for the GIST, but it's a composite values. So because let's suppose it's a composite value, like it's a point is a composite value. It has an X and Y. Both values it has in that. So if you want to create an index on that, you need a GIST index. So here are some additional tips for the creating GIST. Only create index on column that are frequently used in spatial queries. Keep your index up to date. You should keep the index if you add or delete data from your table. Consider using multiple index, create multiple index on different column if you don't have a lot of data. This will help to improve the performance of your query. So that's just tips to creating that. So we already discussed storage, queries, index. So there should be some mechanism because that frequently we have a data in JSON format, in a text format, in a geospatial because it's coming from other sources. So there should be a OGR to OGR like -f, PostgreSQL connection string, and the mydata.json. It will import file into, actually not into PostGIS, into PostgreSQL using PostGIS extension. It will import the data from this. So it can be GeoJSON, shapefile, and KML to import a file into KMS using this. Actually, these are the format we are getting from the geospatial data systems. Because usually we don't have a computer, we have a different system, machines are running, which is collecting the data collecting data, and it has its own formats. So you can use that format and import the data in PostgreSQL. So exporting data, you can export the data too. The same GeoJSON, MyDataJSON, same this, and select static from my table. It will export all the data from my table into MyData.json. So previously we import the data into the table from file. Now from table to export the data into a file. So it will create the same file. You can write any columns there. If you don't want to export all the column, just write the column. If you want to export the whole table, then select static is a good one. So I told you that visualization is a separate thing. Like it's when you query PostGIS, you query that, it will give you the result in a coordinates format and everything. But that's not the solution. Usually you need to have some graphical information. Like if you want to make a line, the line should be drawn on the screen. So there are tools, like PostGIS support variety of tool visualization data, including QGIS, ArcGIS. These are the commercial, and this is the open source, and this is the commercial GIS application. So you can connect that application to the PostgreSQL, and then you can visualize your data. When you say make line, it will show you the line. If you say draw a polygon, it will draw a polygon on screen too. So that's the graphical information on that. So PostGIS is a powerful tool for managing, analyzing spatial data with a database. So I already told you that if you want to, you can do that in a relational database, but if you want to manipulate the data, it's really difficult without the PostGIS. So PostGIS provides you function, indexes, data types to ease your job. Support a wide range of spatial data like insert, update, query, import, export, and visualize data. These are things you require. With PostGIS, you can store all your spatial data in a central location, making it easier to manage and analyze. Previously, we were using the text file, or JSON file, the XML file. We distribute that file everywhere. Now it's in a database central location, so everybody can access that and generate their own reports using their. So I quickly finish it actually, because it's introductory. It's not because the Robert Benner gave the detailed 3-hour tutorial. So if anybody has missed that, it's just a introductory kind of stuff where you can use the PostGIS. So any question, anything?
So when you Percona, when you include that PostGIS into your distribution of PostgreSQL, what version?
The next coming quarter, which is the version, I think. Actually, it's PostgreSQL 15 new release when we are doing the PostgreSQL 15 new release. Maybe in 1 month, yeah. Yeah, actually version of PostgreSQL. We have a PostGIS, PostgreSQL, Percona, everything. So we package actually. So currently we are in PostgreSQL 15, and maybe 15 point something is coming up. 15 point something is coming for PostgreSQL. So we will release that. But at least in a bundle, in a recent days, in a bundle of PostgreSQL, you will find PostGIS and support for PostGIS. Yeah, the commands I give you, you can still install it. Yep. Yeah, that's interesting actually. But the difficulty is that you have to be a geospecialist. Yeah, as if you're a user, and because it's a really difficult field. It's totally difficult than databases. It's totally different field actually. The geospecialists are the different kind of a guy. So it was also hard for me to read, and I am expert in database, but not in a geospatial area. Sometimes I have to read SRID, QRID. What does that mean? Because it's It's different what they are using in that.